Now in this topic, we are going to study about elastic collision in 2 dimensions. Previously, we have done elastic collision in 1 dimension and we have calculated after collision how the particles will be behaving. That is, we have calculated the velocities of the particles after collision. Now we are considering 2 dimension. So here what we are considering is a particle M1 moving with a velocity U1, colliding with M2 at rest. And after collision, they move in different directions. M1 is moving with a velocity V1, making an angle θ1 with the x-axis. And M2 is moving with a velocity V2, making an angle θ2 with the x-axis. This is what we are considering. So let us frame the equations by considering the conservation of momentum and kinetic energy. Remember that it is elastic collision. So kinetic energy is also conserved. Now, momentum, when you are considering, initially the particle is moving along the x-axis. The momentum, remember, it's the vector. So we have to consider the vector components of the momentum. And after collision, they are moving in different directions. So final momentum, when we consider, we have to consider the x and y components separately. So we are going to write the equations based on conservation of momentum separately for x and y axis. Okay. So according to conservation of momentum, so first of all, let us write for x-axis. Okay. For x-axis. You can say initially the particle is moving along x-axis. So initial momentum we can write as m1 u1. And m2 is at rest. So that won't contribute anything. Now look. So here the momentum is, otherwise the velocity is making an angle θ1 with x-axis. So the x component you can write as m1 v1 cos θ1. So I'm writing m1 v1 cos θ1. This is for m1. Now when you're looking m2, m2 is making an angle θ2 with the x-axis. So x component will be m2 u2 cos θ2. Sorry, not u2, v2. So let me write, it is m2 v2 cos θ2. Now let us think about the y-axis. So we said initially the particle is purely moving along the x-axis. So it won't be having any y component. So I can write the initial component of momentum along y-axis is 0. And when you look for the final momentum, the vertical component of momentum of m1, we can write as m1 v1, that is in this direction, m1 v1 sine θ1. So let me write m1 v1 okay, let us think about the y component of momentum once again. So we were telling m1 is moving in this particular direction, making an angle θ1 with the x-axis. So the y component will be m1 v1 sine θ1. We didn't write it. It is m1 v1 sine θ1. Now let us see what about m2. M2 is coming in the downward direction. So the y component will be along the negative y direction. So we can write the y component will be minus m2 v2 sine θ2. Minus m2 v2 sine θ2. So we wrote the equations according to the conservation of momentum. Now we will think about the conservation of kinetic energy. Considering the conservation of kinetic energy, we will frame the equations. And remember, kinetic energy is a scalar. So we don't have to go for the components. We can directly write it. So we can write according to conservation of kinetic energy. According to kinetic energy conservation. The initial kinetic energy is half m1 u1 squared, and the second one is at rest, so it won't contribute anything, is equal to m1 is moving with velocity v1, so half m1 v1 square plus m2 is moving with v2, so half m2 v2 square. So that's all we have to write for kinetic energy conservation. Now, when you're looking into the equations, you see, what we know is, we know m1, we know m2, we know u1, u2 is 0. But v1 is unknown, v2 is unknown, theta 1 is unknown, theta 2 is unknown. That means we have to find 4 variables, v1, v2, theta 1, theta 2. So, you know, if you want to solve one variable, you can do it with one equation. If it is actually equation of 2 variables, you need 2 equations. If it is 3 variables, you need 3 equations. And if there are 4 unknown quantities, you need 4 equations. We have only 3 right now. So right now, directly with these 3 equations, we won't be able to solve these. And so what is normally done is actually experimentally any one of the these unknown quantities, maybe you will find theta 1, and once theta 1 is fixed, then you can find the other 3 quantities using these equations. Okay, so we can write there are 4 unknown quantities and only 3 equations. So what we have to do, we can measure by measuring one of the unknown quantity experimentally. The other 3 experimentally. The other 3 can be found from equation. Okay, that is all about elastic collision in 2 dimensions. So we are just framing the equations, all the 3 equations we are framing, and since there are 4 unknown quantities, we cannot directly solve it. That is what we have to do in this.